Welcome to WB Institution, an online educational app. Modulation. This seems to be a very important topic under communication. It acts as a base for the communication. Without knowing this, it will be quite tough for you guys to cope up with the further advancement. So make sure that you're quite clear with what exactly a modulation is. In this particular session, I'll be discussing about what exactly a modulation is, why it is used in the communication, why, and what are the types of modulations we have. So before that, we have to know what is communication. Fine. What exactly is communication, ma? According to your sense, it is the transferring of information, right? Absolutely, that is true. Transferring of information, sharing of information. Alright, okay. I'm going to consider, see, this is going to be a person A and this is going to be a person B. Okay. Sharing of information between person A to B and B to A. This type of conversation is said to be a communication. Alright. Yes, right? Fine. Under that, we'll be having two different types of communications. One is said to be a wired communication. Can you guess any example? Yes, absolutely. That will be your landline. Alright. Okay. Landline is a kind of wired kind of landline, right? Is a kind of wired communication, so it will get fixed in particular place. You have to move to that particular place and take your call. That is your wired communication. Fine. The other format is the wireless communication. Absolutely, that is your mobile phone. Yes. So example will be your mobile phones. So in that, no wire connection is there. Directly you can move wherever you want and you can attend the call. With respect to the signal is proper in that particular area, right? Okay. So these are the two different types of communications we'll be having. Now, what are the different modes of communications? Means what I'm doing right now is a kind of communication, right? Means that I'm sharing some information through you guys through my voice, right? Right, so under this, voice signal comes under a kind of communication. Okay, at the end of the session, I may ask you guys to write your doubts in the comment section. That is another form of communication. Means that I'm asking you guys to write the questions. Means the text format of communication, right? So under that you'll be having email communication. So these are the different types of communication. So in this session, I'm going to take the voice communication as an example. Okay, so if I consider the human voice signal, we'll be having up to the range is up to 3 kilohertz. Okay, the voice signal of a human being is up to 3 kilohertz, and audible spectrum ranges from 2 hertz to 20 hertz to 20 kilohertz. Clear? So this is the audible spectrum of a normal human being. Fine. So if we consider the frequency range, it's stated as low frequency. Okay, the frequency range of a normal human being voice signal is very low. Fine. Okay, now consider a situation. I want to communicate with a person. See, I'm standing here at a distance of this is myself. Okay, I want to communicate with a person who is standing apart nearly 10 kilometers. Okay, 10 kilometers apart from me. If I shout and say something, is that possible that particular person will hear what exactly I'm saying without neglecting or without omitting a single word? No, right? There will be a sort of distortions in my voice signal. Why? Because it is a low frequency signal. In order to make this in order to troubleshoot this problem, what we are going to do is we are going to introduce a new format of frequency that will be a high frequency. So I'm going to introduce a high frequency with a periodic signal. That is very important. The introduced high frequency should be in the periodic signal, and I'm stating this signal as a carrier signal. Clear? See this the low frequency which we human beings are producing, we can call this as a baseband signal. Okay, baseband signal, or else the message signal. Okay, this will be a very familiar word. Message signal will be a very familiar word. Okay. What is your message signal? That is the original signal which is produced from a particular human being. And what is your carrier signal? It is a added high frequency signal in order to modulate your low frequency signal. Clear? Okay. Under this case, we have three different properties in a particular signal. Just consider a general signal. Okay, normal, in a particular normal signal will be having three properties. One is your amplitude, next one is your frequency, and next one is the modulation. So these are the three properties of in a particular signal. Clear? Okay, what is a modulation? Fine. In the previous segment, I have stated about the low frequency, that is your message signal. I am going to take a message signal. I will be adding the carrier signal in order to get a proper output. Clear? This is what I have explained in the previous part. Right. Now, see, considering this carrier signal, if varying the amplitude or frequency or modulation of this carrier signal with respect to the message signal, this process is called as the modulation. The output which we obtain is a modulated output. Modulated output. Clear? Clear? This is a carrier signal. See, just imagine this signal. The signal which I have drawn, this is called as a carrier signal. Okay, this has a amplitude, this has a frequency, and this has a modulation. Okay, if any one of this property is varied, any one, it might be your amplitude or the frequency or the modulation, any one property of this particular signal is varied with respect to this message signal, that is your original signal which you are giving, right? So with respect to the message signal, the output which you obtained is called as the modulated output, and this process is called as the modulation. Hope you're clear with what exactly a modulation is. Now, why modulation is used? Why we are going for modulation? And we'll be having 2 or 3 important points that is very important, that will prove why modulation is necessary in the communication network. Okay, we'll get to know. First part is to reduce the antenna size. See, this is very important. Why? Because when a signal is transmitted wirelessly, the size of an antenna plays a very important role. That is proved in the following calculation. See, the size of an antenna, L defines the size of an antenna, is directly proportional to the wavelength of a transmitted signal. See, this is the size of antenna. Okay, and lambda defines the wavelength of a transmitted signal. Okay, fine. Of a transmitted signal. Fine. Okay. Now, if I consider the frequency relationship with lambda, it is written as C is equal to lambda into frequency. Okay. Here, C is the speed of light. Okay. This is the speed of light, which is written as 3 into 10 power 8 meter per second. Okay. Speed of light is C. You know already, lambda is the wavelength of a transmitted signal and F is the frequency of the signal. Okay. Now, Example, first case I'm going to consider frequency is equal to 10 kilohertz 10 kilohertz, okay. The first case I'm going to consider frequency is equal to 10 kilohertz. Now, to define the lambda, that is the wavelength of a transmitted signal, can be defined as C divided by F, okay. Okay, this is very important for any competitive exams. Okay, this formula is very important for any of your competitive exams. So C is equal to 3 into 10 power 8 divided by 10 power 4. So you'll be getting some answers like 30,000. Okay, now the size of an antenna is equal to, that is the size of an antenna can be considered as a quarter of its wavelength, that is lambda divided by 4, okay, quarter of its wavelength. So it can be stated as 30,000 divided by 4, so we'll be getting some 7,500 meters. Okay guys, it is possible to obtain an antenna with the size L. What is L, ma? Is the size of an antenna. See this L, size of an antenna. Guys, it is possible to obtain an antenna with 7,500 meters. No, it is quite impossible, right? So here I'm going to modulate the frequency with respect to the second part. I'm going to consider the frequency of 10 megahertz. Okay, this is going to be my second part. Now again, substituting the equation, I'll be getting the value somewhat like substituting in this format only. I'll be getting the equation, a value of size of an antenna like 7.5 meters. Okay, is it possible to get the antenna size in that way? 7.5 meters. It's quite possible. Clear? So now I hope you understand how it is very important. The size of an antenna plays a very important role for the transmitting signal, right? So under this area, modulation is very important. Next is to reduce the interference. So I'm going to state this with an example so that it will be quite easier for you to understand what exactly, how to reduce, why to reduce the interference. Okay, just imagine you're traveling with your 5 friends. Okay, all of your 5 friends are talking to you simultaneously regarding different stories or same stories or whatever. Okay, but the thing is that they are speaking to you simultaneously. All 5 are speaking at a time. Okay, could you able to identify person A was speaking this concept, person B was speaking this concept? Could you able to understand or identify? No, right? That is quite impossible, right? Why? Because we can understand everybody are speaking at a particular time, means to whom we will listen, we can't do. It is quite impossible, right? The same concept is happening here. Okay, among signals, that is with persons here with signals. Okay, I'm going to take a single channel. Single channel is compared to a single person. For example, the example which I stated is you. Okay, so here single channel. Okay, I'm going to consider a single channel. Now I'm going to transmit 5 voice signal. Okay, of a same frequency. All the 5 voice signal have a same frequency. That is quite important. Okay, when this same frequency signals are transmitted to this single channel, the output which I will get is a errored output. Why? Because these similar frequencies will get interfere each other, and the output which will get is a errored one. So this is regarding the without modulation. Okay, this concept is without modulation. In order to eliminate this error signaled output, we are going to introduce a modulation technique over here. We'll see what this modulation technique is actually doing with my signal to get a error-free signal. Okay, now under this modulation process, see each signal the same concept, same structure. Okay, what the modulation technique will do is Each signal will be treated with a carrier signal. Means that a carrier signal. What is a carrier signal? It is a high frequency signal. I have stated you earlier, right? A high frequency signal of a related frequency with a different distance. Okay, the frequency range will be similar, but the distance through will be different. Okay, so each one will be treated with a carrier frequency, which is a high frequency, so that their frequency range will be different, and they are set to transfer to a single channel. The output, here the modulation process is carried out, the output demodulation is carried out, and finally will be getting a error-free message samples. Okay, so this is what the major purpose of a modulation is. Whereas during this process, with the presence of modulation, interference is eliminated. In the first process, without modulation, because of that interference only, we have got this errored signal. Correct. So in the second concept, that is with modulation, the output which we have obtained is a error-free output. Why? Because the interference has been reduced, is got eliminated in the modulation process. So only we are going with modulation technique. Clear? The third one is to allow multiplexing of the signals. See, this actually states the example which I have recently told, that is this is a case of a frequency division multiplexing. Okay, means that each signal frequency is treated, modulated, and it is sent to a single channel. Again, it is demodulated, we have got the output. It is a frequency division multiplexing. Okay, so same thing is it is applicable. Okay, fine. So I hope you understand what exactly why we are going for modulation, in order to eliminate the errors, in order to reduce the antenna sizes, right? Yes. Next is the type of modulation. See, you can see some kind of chart over here. Yes, we'll explain clearly, one by one. Okay, so first concept is modulation. Modulation is widely classified into a analog and a digital modulation. First of all, I have to know what is the analog signal, ma? What is analog signal? It is a sine signal or a rectangular signal, whatever. This is a analog signal. Okay, what is a digital signal, ma? In terms of ones and zeros. Okay, zero, this is your 0, this is your 1, again 0, 1, ones and zeros. Okay, this is a digital signal. Clear? Fine. If the analog and digital representing the message signal, that is your baseband signal. Okay, modulation carried out considering your message signal. If the message signal is an analog signal, that is said to be analog modulation, and the message signal is a digital format, zeros and ones. It is a digital modulation. Clear? Clear? Now, coming under this analog modulation, you'll be having a continuous wave modulation and pulse modulation. So this is typically based on the carrier signal. Okay, if the carrier signal is continuous, that is called as a continuous wave modulation, and if it is in the pulse format, it is a pulse modulation. Okay, this is totally regarding the carrier wave. Okay, the first one, the analog and digital differentiation, is based on the message wave, that is your baseband, the original signal wave, right? Clear? Now again, so under continuous wave, we'll be having three different types of modulations. One is your amplitude modulation, next one is your frequency modulation, and finally phase modulation. Okay, so what is the amplitude modulation? We'll see it. Here you can see a message signal. First one is a message signal, a normal sine wave. Next one is a carrier signal. It is a high frequency signal. Okay, what exactly amplitude modulation is? In the amplitude modulation, the frequency and the phase is said to be constant. Okay, what is that? The frequency and phase is said to be constant. The amplitude of the carrier signal is varied with respect to the message signal. See, the signal, the waveform is said to be similar, but the amplitude is changed with respect to the, what is that? Message signal, with respect to this message signal. Okay, changing of amplitude in the carrier signal with respect to the message signal is called as the amplitude modulation. In this, the frequency and the phase is said to be constant. Okay, now next one is the frequency modulation. Under frequency modulation, your amplitude and phase is said to be constant. Okay, amplitude and phase is said to be constant. Here the frequency is varied. See, imagine this is your message signal. Okay, this is your message signal. This is a positive cycle, positive half cycle, and this is your negative half cycle. Okay, this is your negative half cycle, and this is going to be your positive half cycle, and this is your carrier signal. Second waveform is a carrier signal. Fine. Okay, now the output which you obtained is, there is a change in the frequency. Means that, just imagine, see, this is a point 0. Okay, at 0 there is no change in the signal. Okay, there will be a normal carrier waveform, the carrier waveform which carrier signal which you have given, the same thing you will be obtaining in the first that 0 part. Okay, in the positive half cycle, the peak of the positive half cycle, you will be getting a waveform, that is the frequency will be higher. Okay, you will be having this kind of frequency of carrier signal. Next, when you get into a peak of the negative half cycle, you will be having a elaborated cycle of frequency. The cycle of frequency will get elaborated. Okay, so this is the concept regarding your frequency modulation. Clear? In the frequency modulation. And finally, when you get into the phase modulation, here you'll be getting the amplitude and the, what is that, frequency is kept constant, only the phase is changed. Okay, the carrier frequency phase is got changed with respect to the message signal. So these are the three different types of modulations you have. Finally, so yes, in pulse modulation, it is get divided into 4 different types. One is your amplitude modulation, pulse amplitude modulation, pulse width modulation, pulse position modulation, and pulse chord modulation. So these are the 4 varieties of modulations under pulse. Okay, so here the constant part is that if you consider your message signal will be a sine wave. Okay, the carrier signal will be a train of pulse. Okay, will be a train of pulse. For example, sine wave. This is a sine wave. Okay, this is a sine wave, train of pulse. Okay, zeros and ones. Okay, 0 1 0 1. Okay, this is a positive and negative half cycle you'll be having. Okay, fine. Understood what exactly a message signal and the carrier signal of your pulse modulation will be in. Okay, we'll see independently what exactly a pulse amplitude modulation is. Okay, under that, fine, this is the pulse amplitude modulation waveform. Under this, 2 important points you have to note. One is that the width and the duration remains the same. Okay, the width and the duration will remain the same, whereas the height and the amplitude will vary. And amplitude will vary under the pulse amplitude modulation. This remains same and this will vary. Okay, now consider the message signal is a normal sinusoidal signal. This is a sampling signal. Already I have told that the carrier signal is a train of pulse. Okay, this is a carrier signal, a train of pulse. You will get the output where the height and the amplitude of the signal, carrier signal with respect to the message signal has been obtained. So this is your what is that? pulse amplitude modulation. Next one, pulse width modulation. If you consider the pulse width modulation, this is the opposite of your pulse amplitude modulation, but because in this case height and the amplitude is kept constant, whereas width and the duration is varied. Width and the duration, you can see in this particular diagram. See, this is going to be your message signal, whereas the pulse width modulated signal resist. Here you can see that the height is different, as well as the the width is different. The width is different and the duration of the pulse is different when compared to the message signal. Okay, so you can understand what exactly a pulse width modulation is. Under this, width and the duration is said to be varied. Clear? It will vary and the height and the amplitude is kept constant. Clear? Fine. Next one is your pulse position modulation. Under this pulse position modulation, position of the modulated signal will change the position of the input signal. That is the main concept. The position of the modulated signal will change the position of the input signal. See, this is a modulated signal. This is your input signal. That is your message signal, is the analog signal. Sampled signal. Okay, this is the modulated signal. Okay, finally that will change the position of the input signal. See, the position of the input signal has been varied. The position has been varied, right? So this is the pulse position modulation. And the final one is the pulse code modulation. Under this, you can see this is your analog signal. Okay, this is your analog signal. Sampling at this analog signal is got sampled at a different interval. Okay, this is get sampled. You can see a irregular waveform. Okay, this is the sampled at different interval. Okay, different interval. The input signal is got sampled at a different interval, and it is get quantized. Okay, you can see the signal has been quantized. Finally, it is get encoded with the help of a analog to digital converter. Clear? This is the process which is happening in the pulse code modulation. Fine. So these are the basic concepts regarding your pulse modulation techniques. For detailed explanation, stay tuned for my further sessions. So next type of modulation we'll see is the digital modulation. Under that we'll be having 3 different types. Yes, we have come to the final modulation technique, that is going to be your digital modulation. Okay, under digital modulation we will be having 3 different types of modulations. One is your ASK, FSK and PSK. What is that? ASK, FSK, PSK. What is that? ASK represents the shift keying. Okay, SK is the shift keying. Okay, now ASK means amplitude shift keying, FSK frequency shift keying, and PSK is the phase shift keying. Okay, fine. Already I have explained about the basics of digital modulation. Means what is your message signal, ma? It is a digital signal. My message signal is a digital signal. What is your carrier signal? It is a analog signal. What is your carrier signal? It is a analog signal. The combination of the digital and the analog will result in some kind of signal with respect to the amplitude shift keying, frequency shift keying, and the phase shift keying. Clear? That is what exactly a digital modulation represents. See, for example, I'll state an example here. I'm going to take what is your message signal? That is your digital signal, right? Just imagine this is going to be my digital signal. My drawing is not perfect, but still adjust it. Okay, fine. This is your message signal, digital signal. This. Okay, now plus the carrier signal. What is your carrier signal? I have stated it is a analog signal. Okay, the combination of this with respect to some limitations, I'll be getting the results for amplitude shift keying, phase shift keying, and your frequency shift keying. Clear? Now we'll check what are those limitations. Okay, so if you consider your amplitude shift keying, the amplitude of your carrier signal is varied with respect to the message signal. This is what the amplitude shift keying. Whereas in the frequency shift keying, the frequency of your carrier signal is varied with respect to your message signal, and here the phase is varied. The phase of your carrier signal is got varied with respect to the zeros and ones of your message signal. So these are the basic concepts regarding the modulation technique and its types. So in order to know know more about this modulation technique and to get a brief detail, let me know your comments in the comment section. And if you want to get a detailed information regarding any of the concept, please write your opinion in the comment section, so we will get to know. Thank you.